We were at the very end of section 6.6, but we hadn't talked about vertex form yet. Okay, so we write things in vertex form when it's in the form it's in the form y equals a times x minus h squared plus k. So that's what I kind of have here. So y equals a times x minus h squared plus k. When you have something like that, it talks about how it's been shifted. So we talked about all of the transformations last time. So if I had something like y equals 2 times x minus 3 squared plus 5, you would know that it shifted to the right 3 and it went up 5 from the parent function. So think about that. If I go over 1, 2, 3 and up 1, 2, 3, 4, 5, that's telling me where my vertex is. And then the 2 is just telling me that it's skinny, right? It's a vertical stretch. So it's going to look like this. Okay, so that's what why we call it vertex form, because you can easily tell that the vertex is at h comma k, because it's been shifted right h units and up k units. So last time we left off with problems like number 1, where we had 4x minus 8 squared plus 3. And you had one like this on your homework, or I think you had 2 like this on your homework. And you had 2 transformations in there. You had a 4 and an 8. So you had some kind of horizontal compression and some kind of shift. But we found out that it wasn't really shifting to the right 8. It was really only shifting to the right 2. Do you guys remember that? Did the graphing calculator? So what we have here is we would pull out the 4 and have x minus 2. And then we would square it. So we would write it as 16 times x minus 2 squared plus 3. That is in vertex form. So that's all I'm asking for those first 2 problems on your homework that you guys have the vertex form on. Okay, on the other 2 problems, like 11 and 12, I think, I told you to skip them right now because we hadn't talked about completing the square. Now, we've done completing the square before in section 6.4, but this is a little bit different. Okay, so this is when it's already like f of x or y equals or whatever. Okay, so it says you can write any quadratic function in vertex form by completing the square. So if I have y equals x squared plus 2x plus 4, what I'm going to do is, normally, like when I had equal to 0, I would subtract the 4 over to the left side. I'm not going to do that here. I'm always going to keep the 4 on the right. I'm just going to kind of ignore it for now. So it's going to be, I'm going to have something that I'm going to add, and then I'm just going to have the 4 over here on the right. But I'm basically keeping everything on the right side of the equation. So when I add a number in here, I'm also going to subtract the number from the same side. And that's when people are always like, well, why would you do that? Why would you add the same number and subtract the same number from the same side of the equation? Right? You'll see. So when I complete the square, I take my 2, right? I do my b divided by 2 squared. So I have 2 over 2 squared. So I get 1 squared is 1. So I put a 1 in here. But since I'm now keeping everything on the right-hand side, I'm now going to subtract the 1 as well. So I'm going to have a minus 1. So I get y equals, and then this portion that is right here can now be written as a perfect square. So I can factor it. I can break it into x plus 1 times x plus 1. So I have x plus 1 squared. And then over here, I have the 4 plus a negative 1. That becomes plus 3. That's vertex form. So can you tell where the vertex is located then? Where do you shift? Left 1, up 3, right? So your vertex is negative 1, comma 3. It's always the opposite sign on your x value and the same on the y. Okay, but this gets a little bit more complicated when you have a number out front. So previously, we would just like divide by negative 2 on both sides, right? And we do the completing the square with fractions. Okay, what we're going to do here is we're going to pull out the negative 2 just from the x terms. So I'm going to have negative 2, and I'm going to have x squared plus 2x. I'm going to leave a little spot, and then I'm going to put my plus 2 on the right-hand side. Right, I just moved my 2 to the right. And I'm going to complete the square. So I'm going to take that 2, I'm going to divide it by 2, and I'm going to square it. So I get 1 again. So that's what I'm adding in. So that's like my little box. I'm adding, and I'm subtracting. So I'm going to do a plus 1, and I'm going to do a minus 1. But here's where it gets a little bit weird. Okay, I didn't actually add 1 on this side of the equation. What I really added was negative 2 times 1. So I added a -2, right? If I multiply that all out, I added a -2. So what I really need to add is not a -1 in that box. I really need to add a +2. Okay, so I need to multiply that by a -2. So what I do, I stole this from someone. I tutor someone, they did a little house, and I was like, oh, I like that little house. I'm going to steal it. All right, that -2 I write up here. So I remember I have to take that -2 times the -1. So then I have y equals -2 times x plus 1 times x plus 1, so x plus 1 squared. And then I have +2 plus, and now I multiply these two items, and I get +2. So I'm going to have y equals -2 times x plus 1 squared plus 4. So your vertex is at -1, 4. So I want you to try the same thing on C. Draw the little house shape. So you're going to set it up. You're going to pull out the -3 just from the x terms. The -15 is going to go to the right. You're going to have your little box here, and you're going to have plus the box with the house. And in the top of the house, you're going to have a -3. So go ahead and try it and see what you get. All right, so on this one, so you pull out the -3, so you should have an x squared and a -4x. Okay, so then you need to complete the square. So you take the -4, you divide it by 2, and you square it. So you have -2 squared, which is +4. So that's what you're adding. So you're adding it here, and you're doing a -4 on the other box, because they're on the same side of the equation. So when you do that, you have a -3. It factors into x minus 2 squared, and then you have -15 plus 12, right? Because the -3 times -4 is 12. So -15 plus 12 is -3. That is your vertex form. So your vertex is 2, -3. How did I get x minus 2? I factored the x squared minus 4x plus 4. So I factored it into x minus 2 times itself.
What do you say in the little triangle?
-3. You always put whatever number you had here in the little triangle. So you don't have to do the little triangle. It's just kind of a way to remember that you need it. That you need the -3. All right, and the last one, it says find an equation for a parabola whose vertex is at 1, 2. So that's your HK. It told us the vertex. And then passes through 3, 4. Yeah, Allison? How do you know what x is? What do you mean?
Like 2 -3.
Oh, you're like when you have like y equals -3 times x minus 2 squared minus 3, like how do you know how it moves over?
Yeah.
You know that it shifted right 2 because inside the parentheses it's always the opposite of what you think. Remember, -2 means go to the right 2, and then the -3 means you go down 3.
Oh.
So it's 2, -3. So it's always the opposite for the x one. All right, so if I write my my equation for my vertex form, it's a times x minus h squared plus k. So I have x minus 2, no, not 2, x minus 1 squared plus 2, my h and my k. And then I need to find what a is. So I don't know what a is. Okay, this kind of takes you back to like Algebra 1. Do you guys remember when I gave you guys, well, I didn't give you equations in Algebra 1, but when you had things like 3x plus b, and you were like, oh, I need to know b, but I know that it goes through the point -1, 2, right? If it goes through -1, 2, you would just plug in -1 for x and 2 for y, and then you could solve for b, right? This is the same concept. We have a parabola. We have a point that the parabola goes through, but we don't know what the a value is. We basically don't know how like skinny the parabola is, or if it's like facing up or down, really. Okay, so I'm going to plug in my 3, 4 for x and y. So I'm going to have 4 equals a times 3 minus 1 squared plus 2. So I get 4 equals a times 2 squared is 4 plus 2. So I have 4 equals 4a plus 2. I'm going to subtract the 2 over and divide. So you end up getting a equals 2 over 4, which is 1/2. So that's your equation. You have y equals a, 1/2, x minus the h value, which is always 1, and then plus the k value in this case, which is always 2. The only thing that changes are x and y. Like it could go through any point on that parabola. So we keep those as x and y. Does that make sense? Okay. Now, if you panic, and let's say I ask you write the equation in vertex form, and I have you complete the square in order to do it, and it's something like B or C where you have to pull something out. If you're panicking on the test, how else could you find a vertex? You could use a t-chart, or you could use a formula. What formula? No. I think you guys are going to say quadratic when I use the word formula. What equation finds the vertex? Negative b over 2a, right? It finds the axis of symmetry. Then you plug that in to find the vertex. So couldn't you just do that? Couldn't you multiply it out? Or like on b, couldn't I do negative b over 2a? Get the x value, plug the x value in to get the y value. That's now my h and my k. What is a? In this case, on part B, it's negative 2. It's still the same thing as ax squared plus bx plus c. So you can also get it that way. So like in that example, if I did negative b over 2a, I'd have negative 4 is 4 over 2 times negative 2. So I'd get negative 1. I would plug in, so I'd have negative 2 times negative 1 squared minus 4 times negative 1 plus 2. So what do I have? Negative 2 plus 4 plus 2. So I can get 4. So your vertex should be negative 1 comma 4, which it is, right? So then you would just plug into the vertex form. You'd say y equals a times x minus a negative 1, so plus 1 squared plus 4. And then you would put the number in front. You put an a, which was right here, negative 2. So you could still get it. You don't have to complete the square. So don't freak out and say, oh my gosh, I have to complete the square every time. Now, is this a good method to learn? Yes, because we're going to have to do it later on. When we get to parabolas, hyperbolas, ellipses, yeah, we're going to have to do it. Yeah. Okay.